welcome back everyone, respected professor, attendant and participants. I hope you set your energy on a high for our next session on remote sensing and machine learning. For our next session, I would like to invite Dr. Vikas Kumar Vidyarthi sir on the stage. Dr. Vikas Kumar Vidyarthi sir is an assistant professor at NIT Raipur, Chhattisgarh. Sir holds his BTech in civil engineering from MIT Muzaffarpur and MTech and PhD in hydraulics and water resource engineering from IIT Kanpur, India. With over 16 years of teaching and research experience, Dr. Vikas Kumar Vidyarthi sir has worked on the prestigious water resource project and holds a patent for an innovative flow meter technology. A prolific author and a reviewer for reputed journals. Sir has delivered expert lectures on globally and received multiple accolades, including the Young Researchers Forum Award.
Now, I would like to invite Saroj Meena Ma'am, Associate Professor, Civil Engineering Department, VIT Sindri, to felicitate Dr. Vikas Kumar Vidyarthi Sir, Assistant Professor, NIT Raipur, by presenting him a token of appreciation.
A huge round of applause for Vikas.
Remote sensing and machine learning are widely used in land use, land cover, analysis, and prediction. Remote sensing provides high-resolution spatial and temporal data on Earth's surface, enabling accurate LULC classification, machine learning algorithms such as random forest, and support vector machines.
Dr. Vikas Kumar Vidyarthi sir is an accomplished researcher in the field of remote sensing, machine learning, and land use analysis. His talk will explore in the integration of these cutting-edge technologies for the land use and land cover analysis and prediction, a critical aspect of sustainable development and planning. Please join me in welcoming Dr. Vikas Kumar Vidyarthi sir to the stage.
Okay, thank you so much for my introduction. So, I just am very much pleased to come here as in physical mode, and I'm very much thankful to all the coordinators. Is it required? Am I not audible to last audience? Audible without this? Okay, fine. So, I am very much thankful to the chief patron, and all the coordinators of this 5 days workshop on application of remote sensing and GIS in research. And thank you so much for inviting me for this guest lecture. So I will be talking about something related to a very important and cutting-edge technology right now utilized in most of the domain of science and coupled with the machine learning techniques to solve different kind of problems. Either it is of social or it is related to something defense, right? So here what we will talk is the remote sensing, which will be utilized to find out the predict the LULC. You must be knowing what LULC is, land use and land cover, right? So that how you can predict it for future. So if you can predict the LULC, you can have a better policy for that particular city, right? How much the area will be going to change in the near future, right? So in that way, these two techniques, when you are just merging together, remote sensing and machine learning, this will finally, you can predict the future LULC changes. So this talk will be basically on that only, and I will just show you some case studies which my MTech student has carried out. And so these things you must be knowing. There is no any field, that means domain, which GIS is not entered. any field you just consider and there is a GIS. Either you talk about the mineral exploration that this area is known for, either you talk about defense and military, either you talk about navigation or natural process management, natural resources management, or any field that you talk about, there is a GIS, utilization of GIS. In our civil engineering, this is exploited too much. Okay, this particular technique is exploited too much. It is basically based upon the imagery. So you have a map, and whatever the things you want to know, you just overlay on these particular imagery to find out the information. Okay, so this is nothing but a GIS uses a layer-based information model to describe the land. So whatever land you want, there is an imagery, you just have to lay over one particular information layer on that. As for example, if you are in the field of hydrology, you want to know the area which contains the watershed. As for example, Damodar river is going through your region, right? So how this is behaving, how it is going, and what is the movement, how much the slope of that particular area from where the river has started and where it is going to be end. So you will use the imagery, and then you have a layer which is based upon hydrological units of that particular area, and you just overlay on that, and you will have the GIS based information model, right, to describe that particular land for your use, right? Let's say if somebody is from administration, he can just overlay one particular administrative information layer on that, and then you will get that particular information map. Is actually in 1993, we were facing a lot of challenges for introducing the remote sensing, means the satellites, as well as, or developing the satellites, as well as developing the vehicles that your satellite can be just launch. So two things were there. One was to develop we were facing the challenges in developing the satellites as well as the launching vehicles. That was the time in 1993. The first IRS, which was launched by PSLV, our first vehicle, launching vehicle, and that was failed in 1993. Later on in 1994, so what are the satellites? You all are knowing, right? So different purposes we are using here. I had just summarized some of the uses or the areas that agriculture, water resources, forestry, ecology, geology, watersheds, marine fisheries, or coastal management. This is very few, right? So many things are there which the information are taken by different satellites which is actually running in the space or launched in the space by different countries. So India as a whole, when in 1993 the IRS was failed due to the what you can say, the launching vehicle, that is PSLV. Our satellite was good, but what was happened was the PSLV was not launched it properly, and due to that it was crashed. The first one, that was the time in 1993. So we were taking help of Russia or any other country. Most of the satellites were launched by Russia, our indigenous satellites. So currently we have in India 47 total satellites are launched by our own PSLVs, and very advanced PSLVs are there now also, and also the satellites. So there is no any area which the India don't have in the space. And we are having the good data set. Different agencies are there. You must be knowing the BHUKOS. How many of you had used in your research BHUKOS? Anyone? No one. Okay, so in BTech project also you can take those helps. If you are not MTech student, that doesn't any problem. You can start downloading that from the BHUKOS and start using them, right? BHUKOS, BHUKOS. Huh? Bhunidhi, another one, but BHUKOS, you will get more maps on that. So resolution, you may get 12.5 resolution like that. So some other data set are also there, Sentinel and Cartoset. You can take from other agencies, but BHUKOS is one where you can get major or lots of information maps, right? So this was the situation of Indian remote sensing satellites and the launching vehicle. So currently we are having Cartoset 3A and 3B. That has to be launched in this year only. I'm not sure what is the progress, but it is planned, already planned in 2024. Now, the GIS applications in water resources engineering. So I already said that different science and other domains, there is a GIS, use of GIS. But here in water resources engineering, especially I am from water resources engineering, so I will just talk about in this talk majorly in water resources domain applications. Okay, so here we have a major verticals in water resources. You must be knowing surface water hydrology. Another one is water resources planning, that is related to hydraulic structure and open channel, and then groundwater hydrology, and then environmental conservation. So all these four verticals comes under this resource management, you can say, or water is one of the resource, right? Now, when we talk about the groundwater, it is very difficult. If you are not seeing a thing from your naked eyes, the satellite can also not see. So how will you utilize the groundwater hydrology? So many places you must be knowing that when you are utilizing or just downloaded a map, that is very erroneous. Why? Why we say like this? Because of the cloud cover. When there is a cloud in the atmosphere, what's happened? The satellite is above that cloud, so that cannot be seen by that particular. Whatever the situation is there at that day will be not seen by the satellite. Okay? So we have to remove the cloud cover from that particular map before using it, right? So when I am saying this groundwater hydrology, we cannot directly see the groundwater, right? Can we? We cannot. But we can say that which particular section or which particular area is very good in water resources, right? If you are just settling down near to the river, okay, then you can say that this particular area will be good in water, means groundwater will be more, right? If you are going to Rajasthan, where the rivers are almost dry, right, and the rainfall is not very good, then at that particular location when you visit, then you can say that no, the groundwater will be very low, right? But this is our sense, this is our information of that particular area that just ask me to say this, right? Otherwise not. So groundwater we cannot see from our eyes. So that's what the satellite also. Satellite can also not see the groundwater directly. So how we can utilize this groundwater measurement? So people are saying that real-time monitoring of groundwater, right? So real-time monitoring of groundwater will be done by the information that we had collected from our senses. The same thing done by the satellites also, and there is a GRACE data, which is gravity recovery climate experiments, that is GRACE, right? So by the use of other information, there is a relation between the groundwater level and other informations. So if let's say we have a function like as y is equals to, y is a function of x1, x2, x3, x4, right? So this f may be a linear function or non-linear function, linear regression or non-linear regression, or any machine learning techniques. So if your relation between the independent and dependent variable are highly non-linear, then non-linear relation will be the function, right? That function will be a highly non-linear function. So in the similar fashion, the groundwater level will be a function of other variables, x1, x2, x3, right? It may be rainfall, it may be other things, right? So here, the GRACE data is actually, it measures the changes in the Earth's gravity, and it tells about that what is the water resources are increasing or decreasing. So on that basis, they are just developed the ecology and other things. Now, another thing in water resources management, whatever the four verticals I had told you, the stream flow, that is basically the most important thing which we need to predict, project or simulate in most of the water resources planning and management. So if we talk about surface water management or surface water hydrology, where it plays a very big role, the stream flow forecasting, how it helps, it predict and prepare for extreme weather conditions, drought and floods, right? In surface water hydro. Water resource planning, how you'll just manage the reservoir and how you allocate the water for different purposes, agriculture purposes or municipal purposes and all these things. So stream flow in all these verticals are very, very important. In hydropower generation, you will know if you forecast the hydropower stream flow in advance, what will happen, you can know that how much water will be available at what time, right? So stream flow prediction and simulation is very, very important. Likewise in environmental conservation that I talked about. Now this stream flow is actually uh, the 10 years before or 20 years before, when we were talking about stream flow, it is just like a water balance model which we say everything about, right? Nowadays, due to these two players, climate change and land use changes, there is a major changes in a stream flow has been registered, because these are the major players. Climate change, due to the climate change, what's happening? The temperature, Earth's temperature is increasing, right? And due to that, and the precipitation has abrupt, what you can say, heading, it's happening very, very irregular, right? A very large rainfall is just occurring in a very short interval, right? That is, the rainfall has not decreased. What happens is the duration has decreased, right? And that resulted into floods, है ना? And so another way, when temperature rises and the rainfall is very, very less, in that condition there is a drought. So these two are actually impacting the stream flow, isn't it? Which type of hydrograph you will get in a particular location of a basin, that will be due to the land use, है ना, changes. So if your area is what you can say not very much pervious, then due to the land use and land changes, what's happening? The impervious surfaces are increasing in the area, and due to that the hydrograph, the shape of the hydrograph is changing rapidly. And so these two are playing a very important role in stream flow. And so in this particular, when we just saw the literature behind it, few of the research gaps which is found, that the comprehensive projection of LULC changes is very few and far, and mostly missing in different river basins. So in different river basins, whatever the people has till now projecting the stream flow without considering these LULC changes. They are taken the value of impervious, area of the impervious value, and just utilizing that particular impervious value in their modeling. But your LULC still is going to change every year, right? And those things has not been taken into account. So first gap. Second gap was the previous studies lack the incorporation of CMIP6, though I am not showing any result of second, but I am just writing down here the research gap. CMIP simulated data for stream flow projections in different river basins, emphasizing the need for integration to enhance projection accuracy. And then after, the previous studies lack a comprehensive assessment of applicability and limitations of deficit and constant loss methods. So HEC-HMS is one of the hydrologic model. Any one of you must have utilized it, might have utilized it in your projects. So this is the deficit and constant loss method has not been utilized till now very much, though it is very, very easy and very simple. Then the previous study, the comparative analysis for projection of a stream flow using HEC-HMS and data-driven techniques are few and far. And I am talking about projection period, not the historical period where you are developing your model, right? So developing of the model has been done a lot. You will find out hundreds and thousands of papers on this particular topic, but you cannot find what is the good, means your data driven technique or your conceptual model is good in the projection time has not been given. So the objectives with these research gaps, the objectives have been formulated to develop LULC projection model using NN and analyze its trend for assessing the temporal changes in LULC patterns within the watershed, to implement HEC-HMS conceptual model with historical observation data to simulate a stream flow, and to compare the stream flow projections derived from process-based HEC-HMS model and the data-driven models. So related to those research gaps which I have shown, nearly 11 objectives were created by my MTech student. We had just developed 11 different what you can say objectives, and he worked on all those 11 objectives. I am showing only here 3. Now a study area. What is the study area? A study area is the Mahanadi river basin. This is the map you can see here. Sorry. So here is the location of all the data which we had collected from different sources. I'll just tell you where it is, from where we had just calculated, and the place where Jondra is there where we had just calculated the gauging station, Basantpur. So that is Basantpur, right? One place is there, Basantpur, on the river stretch, and there we have calculated the stream flow, right? Predicted and projected the stream flow. So these are the data which is obtained from different agencies. The DEM here, Bhuvan, and then Delhi data, WRIS site, and then NASA, and then IMD Pune from we got the rainfall data, soil map, FAO, and LULC Earth Explorer. So these are freely available data sites. You can also download them easily. So now talking about the first objective which we had he just done in his research is the modeling land use land cover transformations, because this was not included in the development of the hydrologic model, HHMS, or any other model which utilizing the land use and land cover. So modeling and forecasting of this LULC. And then hydrologic modeling using HHMS and data-driven techniques, which had been done by the utilization of land use land cover changes, which has been taken in the development of the hydrologic models. So this is the flow chart. The collection data of the data collection LULC map from 2001 to 2022. Total 21 years or 22 years of data we had collected, the maps we had collected, but many maps were having lots of cloud cover. Okay, so in 1 year, only one map has been considered, and that is the representative map of the whole year, though this is not very well to say, because your land use land cover changes will be different in different seasons also. If you talk about the, but what we had done is the date we had taken as same, either the previous monsoon or post monsoon. You can take both if you are able to remove the cloud of your area, cloud cover of your area. And then actual observations, LULC map for 2022, we have this, and then the inputs were just checked with the correlation analysis, and then transition potential modeling were developed by the use of MLP, ANN, multi-layer perceptron, ANN model, and then simulation using cellular automation, that is a part of MLP, and then validation has been done. This is projected, the LULC has been projected for this model, developed MLP model, and this is observed model, so this is validated, right? Because the historical data we can always validate, but the projection data you don't have the actual data, observed data, right? So we cannot validate it, right? So for historical data we had developed the model, and then we are saying that this particular accuracy will hold for the future projection also. So here the projection of LULC map for 2027 and 32. 22 till 22 the data has been was there available, historical data. So development of the model has been done, training and the validation both for 2001 to 2022, and it is validated. Then 2027 and 32 has been projected by the use of data, and then the trend analysis, what is the trend of different areas available in that particular area, is also done. And then pattern of the various LULC classes has been recommended. So this is the result, which these are the observed LULC maps, which is of 2012. You can see here I am not giving the entire data set, rather few of the representative data. So here it is of 12, 17 and 22. 5 years interval. So these data these maps are available, okay, observed available maps, right? So these are different LULC. I'm not sure you can be able to just see these things or not. I'll just show in the table also, okay? ये दिख रहा है? Huh? Okay, so I will just show it in the table also. Now, what are the input values, what are the inputs that we had taken into the ANN MLP models are the aspect, slope and hillside map. So these are the three inputs which we had taken for our input, and these are the maps for these three aspects, the aspect, slope and hillside map. That's what I was telling you, that the imagery and then the layers, that information you want, right? So that is aspect that I want. So imagery is this entire thing, right, the boundary, and then lay over one particular aspect, right, aspect information. And so you have aspect map. In the similar fashion, slope map. So the information, this is saying the slope. Here you can see the numbers, right? Here you can see the aspect, right? Here what is there? Hillside. Okay. So these are the information of different maps that I already said. Now, by the use of those three data sets, 5 years of historical data set of the maps, we had just projected for 22, 27 and 32. 32. Okay, so 5 years interval. So here you can see 22, for 22 it was also available. So we can validate it, right, with our projected value from ANN, isn't it? So here it is for 22, and the accuracy has been just checked here only, right? I will just show you in the table. And this is already published. So here with the kappa coefficient, what is the value is the slope aspect and hillside. Here the kappa coefficient is giving kappa coefficient is the accuracy check, right? As for example, RMSE you must be knowing, right? So there is a formulation between observed and projected or simulated value, right? So on that basis, we had calculated this kappa coefficient, and this kappa coefficient is giving that the slope aspect hillside is, when we had taken the combination, these combinations as an input, the value of the kappa coefficient is 0.852, right? In the similar fashion, all these things. So here you can see this value is the highest one. And so, as I just shown you that these three were taken as the input. How? So for that, we had just calculated the kappa coefficient, and we found that with the different combinations, which combination gives the better kappa coefficient, right? So on that basis, we have selected the input value. So here, the slope aspect and hillside, when we keep, the kappa coefficient obtained was 0.852, right? Well, rest of them is nearly same, but this is the highest, so we had taken this one, though any other can also work out. Now, the initial LULC that you were having 2002, 2007, 2012, right? This is projected. Each time we had projected. Here it is 2007, this is final one. For 2002, this is 2007, that is the final one. And we had projected it for 2012, right? So all these data were available. For 12 also available. So for this, the kappa coefficient is 0.829. In the similar fashion, the initial LULC was 12, and then final LULC is 17, and projected LULC was at 22, right? So 22 data was also available. So we can validate it with the kappa coefficient, right? Now, for 10 years interval, if we had just developed the model with 10 years interval, what is the value? So here it is 2002. Of course, if you are checking the changes between the shorter interval, your kappa coefficient will be more, isn't it? 5 years interval, and then you are looking for 10 years interval. So your kappa coefficient will be less, isn't it? Because in 10 years, the area will dramatically change, some part, isn't it? Due to the development of different projects in that area. So here 10 years interval changes, here your kappa coefficient is less as compared to others. Now here you can see the table that I was talking about in the map that I will show you. Here the land cover area for various classes from 2012 to 32. So what's happened in the area? Because area is same. Area is 100%. You are considering the 100% of area. It is converted from one type of land to another type, isn't it? If forest cover is there, maybe some due to some project, it will be converted into some other thing, right? So here the classes were, LUC classes were forest, open served land, tree cover, grassland, permanent wetland, cropland, urban and built lands, cropland, natural vegetation, mosaics, barrens and water bodies. So 10 classes are there of that particular area. In 2012, what was the area in kilometer? What was the 2017? The area has changed. How how it has changed, right? And then in 2022-27, how it will be changed, right? How was up to 22, how it will be changed in 2027 and 2032, if the same transition matrix will be followed, right? So area has changed it, right? Now, in percentage wise, if you say what are the changes in the area, so one area has just converted into another type of area, right? Area is same, but one part of the class is converted into another class due to the transition matrix. Yes. Which one? No, no. You are talking about this one. This one. No, this is very small change. What's happened is in that particular region, whatever the project is there, it is dependent upon that. If project has been built and it may be temporary type of projects which has been removed from that area, maybe that may be the situation. If you are talking about a small area, you can visit there directly, and what changes has been registered, you can directly notice. So that is based upon your transition matrix. It is not validated. It cannot be validated, right? It cannot be validated. The validation is till 22 because you have observed data, observed map. For this projected value, the data cannot be. You have to just, what you can say, consider that transition matrix as the accuracy that hold by 22, it is hold by 32 also. On the basis of that, it has been for 32 and 27. Got it? Now, the LULC area changes analysis for observed LULC of 2022 and projected LULC. So, the area wise, how it is changing in from 22 to 27, 22 to 32 and 22 to 32, how it is going to change. So, percentage, if it is positive, it is going to increase. If it is negative, it is going to decrease. So, I will just conclude what will be the, depending upon these tables, what will be the conclusions. Okay? So now the depending upon different LULC classes, the Mann-Kendall test has and sense slopes has been just considered to know the trend of that particular area. If we are talking about the forest, how the area is, how these changes are, what is the trend of that particular forest, forest land, what is the trend of changing or what are the changes of that particular area, that means forest, will be there in near future. So that can be obtained by these Mann-Kendall tests on performing on forest only, open shrubs only, tree cover only. So area has been taken for different periods, and then trend analysis has been done by the use of this MK test and sense slope, and on that basis this has been developed. So this is the Mann-Kendall test results. So here what you can see here, forest land is going to increase. Forest land is going to increase, right? From 21, what it is, 24 and 31. Then here it is permanent wetland. It is also going to increase. So due to the, when you visit in the Chhattisgarh region, the improvement of the, what you can say, the ponds and wetlands has been taken care by the government, and it is noticed that this is increasing. Till 22 they had just restored many ponds and wells, right? So till 22 it is increasing. Now croplands, here it is cropland. Urban and built up lands. So these are the trends which will conclude in the last, when we will come on the conclusion part. Here now hydrological modeling. What is the use of this LULC projections? So we had projected the LULC. What is the use of it? How we will utilize it? So this particular land cover changes can be utilized by any policymaker, isn't it? If it comes to water resources department, they will utilize differently. When it is going to land department, land management department, right? So they will use it differently. Okay, so till now LULC has been projected. Now the use of those LULC, projected LULC, where we will utilize it, right? So it is for hydrological modeling, where the Hake HMS model were developed without considering the changes in the LULC. So two types of models were developed. One is Hake HMS, another one is data-driven techniques. Hake HMS is a physics-based model, you must be knowing, and the physical parameters and extensive calibrations are required. More informations are required in your conceptual models. It is based upon, it is simply the water balance equation, right? So in the case of water balance equation, you have different kind of inputs required. So those informations are required in Hake HMS model. And then the data-driven techniques, there is no requirement of any physics in of the system, right? And that's why they are called as the black box model. Now, this is done by the hydrologic model by the use of Hake HMS, right? So, if you are using Hake HMS, you must be aware about all these things, right? It is developed by US Army. I am just skipping it. Now, the thing that I was talking in the research gap, that the model which is having the runoff volume models, they are having a different kind of methods, initial and constant rate method. And all these methods are there, but this method is very simple and has not been explored much, right? Another one is SCS-UH method. This is more or less has been utilized by many people. Then linear reservoir has been taken in this particular modeling, and here Muskingum method, you must be knowing the flood routing methods. So this is simple flood routing method, that is Muskingum, you must be knowing this, right? I will not talk about this Hake HMS, details are there. So what is there is, we need the DEM, right? So DEM that you had already projected. DEM and then pre-processing, basin delineation, and then the utilization of these three in the hydrological modeling, right? So the need of the data is precipitation, temperature, stream flow, evapotranspiration, and the LULC that you had already projected, apart from DEM, right? And the time series data, then meteorological model, and then control specification, simulation discharge. So we are just finding out the discharge at Basantpur, and this is statistically evaluated, and by the use of these different statistical measures. In the same time, what is there, the hydrological model will have different things, the components, and which requires the soil map, LULC map, and fitted parameter. This is the role what we had done initially, right? LULC map. So which LULC map? 2022, 2032, 2027, 2012, which map? So people were using the historical maps, right? Not the projected one, or by the consideration of the projected maps. What is the area, how it will be converted in the future? So again, this Hake HMS, the descriptions of Hake HMS, I am just skipping this also. Now, by those models, when we were just utilizing this to be find out from 2001 to 32. Now, year-wise data we have, isn't it? The percentage of impervious due to the LULC projections we had already projected by the use of ANN MLP and remote sensing satellite data. So these things from 2001 to 32 we have now for all the basins, sub-basins that we had. And so majorly we found that it is here percentage of the impervious stayed within the nearly equivalent range between 16 to 19. Okay, and so the percentage of impervious will stay consistent for future scenarios also, right? So by the future projection of your LULC by the use of GIS techniques, this particular thing has been come into the picture. And these are the formulations that now by the what is the range, this particular person has just given the ranges, that how sometimes you will be asked that why you had why you are saying that this is very good. So this gentleman has given this particular table that will tell you that if your R square value is between 0 to 9, 0.9 to 1, then your model is very good. So I had just given it for the information purpose. Though this is not exhaustive, depending upon the conditions, when you are modeling the weather conditions, right, rainfall projection or predictions, the accuracy level of 0.5 is found to be good sometimes. So it depends upon the variables that you are modeling, right? So, but this is guidelines, right? So the results which we had obtained is during the calibration period, validation period, daily flow and monthly flow. These are the values of R square, NSC and P bias. Monthly it is increasing. And so the comparison of daily observed and simulated stream flow during calibration period, which were from 1986 to 2010, and 11 to 2018, 1986 to 2010, 11 to 18. So these are the scatter plot and time series plots. Now, at the same Basantpur gauge station, we had just calculated the stream flow at by the use of different data-driven techniques: support vector regression, random forest regression, and artificial neural network. These are the descriptions of these techniques. Now, the MVLR, that is the base of these data-driven models. These are the linear regression models. So, if your variables are more than one, so variables are independent and dependent variable, and if you have independent variable more than one, then you must have to utilize the MVLR. And in this case, the x1, x2, x3 may be differently. So in the case of your data-driven techniques, the information required is very, very less. As we were having the use of LULC, here there is not required, right? Because they don't need the physics of the system. Rather, they look over input and output combinations. If you provide the input, once it will be learned by that particular data set, it will provide you the appropriate output at the time of validation period. So how the inputs were selected here? The input selection is based upon the statistical models, right? Since we are not utilizing the physics of the system, in the physics of the system, we are utilizing the basic physical laws that we have, right? Conservation of mass, conservation of momentum, and conservation of energy. So on that basis, we are framing the mathematical formulations and utilizing in the conceptual model. But here, in the statistical methods, the values of input and output relations is to be carefully found out. So here, the input were selected on the basis of cross correlation and the autocorrelation function, and the threshold will define that what lags that you have to take, because the stream flow will have the effect of lagged stream flow values, right? 3 days before, if your K value, that means what is the lag time, that means one particular discharge will reach at another location that is defined for a particular basin, isn't it? So that lag, how much lag is important for you, that will be decided by the cross correlation or autocorrelation functions. So here again, this data-driven models were developed by this. How? The input variables were taken as the precipitation T time interval, precipitation T minus 1, and QT minus 1 were selected as the best, what you can say, correlation with your stream flow, and the division were done by 70 to 30%, and then development of model using 70% of training data set, performance evaluation using statistical measures, all these things. Yes. CNN also you can use. We had. Yes. CNN is the most advanced method, no doubt. CNN we had not used. 3 methods we were having to use, lots of work was there. So I was not just convinced by myself that a student has been to just work more. He has done a lot of work actually. So CNN has been just, what you can say, not explored in this particular research. In another one we had done it, another student has done, I am not showing here, right? Of course, CNN is more advanced. the research also says that you don't need, for hydrological models, you don't need a very high-fi models, right? You can model with a simple, what you can say, rainfall runoff model, which I am showing over here. It can be done by simply ANN with one particular layer and a single layer, hidden layer, and with one particular hidden neuron. You can get a very good results. One neuron. You try. You can try it. And I also had tried. It is working well. It works well. So that research says, they had done with different layers, and they are saying that this much, you are increasing the complexity. When you are increasing the number of neurons or the layers, what's happened? Ultimately, you have increased the complexity of the model. And once your complexity is large, what will happen? The time taken in running your code will be more, isn't it? And secondly, you will have to find out the trade-off between your accuracy and complexity, right? If it is not, you will not, so we say that parsimonious models. What is that? That is when you are freely sending the number of, what you can say, neurons, even a single neuron will, if you increase, the number of parameters will be more, isn't it? And when it is so, your accuracy is increasing by only 0.01%. What is the value of that increase of 0.01? So you have to think about the trade-off between these two, right? Complexity and accuracy. So many times people are working here. I can say that when we are utilizing machine learning techniques, you must have seen lots of papers. कुछ कोई use कर रहा है, something is using, and they are publishing the papers. But sometimes there is no requirement, right? Sometimes we have to just make a nail on the wall, and we had a bulldozer for that. So that is kind of the situation currently. So these are the models. Even MVLR is working good in the case of simple linear regression. Multivariate linear regression is working well here as compared to others, right? These are the results of different data-driven techniques: SVR, FR, RFR, MVLR, and NN. The scatter plot and time series plots. I'll just conclude at the time. I will tell you. Now we had just found that sometimes it is some of the model is working very good, some other model is not working very good, right? So for that, what we had done is we had just bifurcated the entire data set into 3 different classes depending upon the statistics, that if it is less than the average value, it is low. If it is between the average value plus 2 sigma, that is some confidence interval, then it is medium, and when it is greater than that particular confidence interval, it is high, right? Mu and sigma is the mean and standard deviation. And these values came, and we just classified these data into 3 different sets. And in this way, we found that the time series models, time series plots which we plotted, tells something about it. I'll just conclude when the conclusion comes. So here what we had just found is forecasting future LULC pattern is crucial for projecting a stream flow, as LULC directly influences the surface characteristics, vegetation, and impervious surfaces, impacting hydrological processes and water runoff dynamics. Means if the LULC is changing, right, your hydrograph at any particular stream will change, the shape, the time of duration, right? All these things will change, and due to that, whatever the LULC, we cannot take a particular LULC which is stagnant. That means historical. We have to project it, and then we find out the changes that is taking place in that particular area, and that basis we can take one average value. So that is important. Another one is LULC map for 2027 and 32 were projected using 12 and 17. Right? So this LULC map of 27 and 32, it is required only for these 2, right? If you have only 2 maps, you can develop or project the LULC of that particular area for 5 years or 10 years gap. Here, from the tables, what we had noticed that I was talking about, when I will conclude, I will tell. Here the cropland area increased significantly and grassland area decreased significantly according to the projected LULC for the year 2027 and 2032. Okay, so here cropland area is increased and grassland area is decreased. So it may be the what you can say seasonal things, है ना? When you are taking the maps for LULC projections, which type of crop is there in the field. If you are not putting, it should be done very carefully, very cautiously, because if you are taking the maps of before the monsoon period, the crop of that particular area is different. So you are taking that particular thing and for projected period or another map is of after monsoon. So that crop area will be different, right? All the crop will be different. So this should be taken at this particular day, or if you are deviated, not more than a week, so that the same type of crop will be there in that area. Other classes may change, right? Development means different other classes, 10 classes were there, but the cropland must be taken in a very cautious manner. Additionally, trend analysis shows that while there is a significant decreasing trend for open shrublands, grassland and barrens classes, there is a significant increasing trend for forest, permanent wetlands and farmland. Okay, so that is the government which is going in that area, developing those wetlands and the forest cover, they are preserving it. Here, urban and built-up land, water bodies and crop land, crop or natural vegetation mosaics. Now, the values of statistical analysis and graphical representation infer that the developed HEC-HMS model through this study was capable of satisfactorily simulate the stream flow of Mahanadi River at that Basantpur location. It is noteworthy that the performance of HEC-HMS model is very good for monthly stream flow since it is well aligned with observed monthly stream flow that you had seen in the scatter plot. While in data-driven techniques, ANN performs superior compared to SVR and RFR, the result of this technique was also assessed through baseline regression, namely MVLR. Okay, so baseline model we had just taken as MVLR, and it is notable that ANN and RFR perform quite well comparatively SVR during both the training and testing phases. And then the study concluded that the ANN provides more accurate results compared to HEC-HMS in predicting a stream flow. The results were also compared for monthly stream flow and distribution of stream flow across low, medium and high flow conditions. That was the last gap which we had taken into account. While in data-driven techniques, ANN performs superior compared to SVR and RFR. The result of this technique was also assessed through baseline regression, namely MVLR, and it is notable that ANN and RFR, this is the same thing. The study concluded that the ANN provides more accurate results compared to HEC-HMS. This is same thing, I think, copied. So these are the publications of, from this particular presentation. GeoJournal already published. Second one is accepted, and these two are under review. And these are 3 conferences that has been published from this presentation. I acknowledge my MTech student, Mr. Gopeswar Sahu. He passed out recently in 2024, and this was his work only. He is currently PhD student at IIT Kanpur. Thank you so much. If you have any question. If any question, you can ask. No questions? Okay. Yes. Only two years data is enough. 2 years data, yes. 2 years. Actually, 2 ways you can do. One is the hit and trial. So you take more numbers of inputs, right? Because input selection is very, what you can say, in the case of cloud cover, you will not find a very good maps, right? So what we had done is from 2001 to 2022 data we were having. Each year one data. Each year one data, and try to get for a particular domain, that means a week, not more than this. This is very important. So if it is available, you take at least 10 years, but for projection, 5 years projection, you will need 5 years back. Means one if you are taking for 2001, after 5 years, means 2006, then likewise this, you have to take the data. And take more number of inputs, and then you just find out the errors. If it is improving, take more, otherwise no. So this is the simplest way you can do. Otherwise, one more method is there which ARSGIS is providing. Directly you will put and they will take and they will model it, but you will not know that how many number of data set it is taking. In ARSGIS they have the plugins for that. Source मैंने बताया था, एक slide में था. I am just showing again. You just take a photograph of it. Yes, this one. This one is the source of data. So LULC, for LULC will get Earth Explorer, USGS. All these are free available. Okay. So if you have no any question, I am concluding here. Thank you so much again. All the organizers, patron, chief patron, and all the conveners. Thank you so much. बैठना है ऊपर. It's not required.
Thank you, sir, for your comprehensive and thought-provoking session. Your insights into the role of machine learning in geospatial analysis was indeed groundbreaking.
Now, we would like to invite Dr. Chitu Huzur sir, Head of Civil Engineering Department, to express our gratitude by presenting a memento to Dr. Vikas Kumar Vidyarthi sir.
हिल गया लगता है ऊपर वाला. अच्छा सामने आ जाए. उसका फर्स्ट पेज इसमें डाल दो. फर्स्ट पेज फोटो आ जाएगा. वहाँ पे आ जाए. हाँ वही सही है. हाँ नहीं ठीक.
Give a huge round of applause.
इतनी जल्दी में कहाँ जाते हैं?
Now we will move for a lunch break, and after the lunch break, we will meet here for our next session at 2 p.m. in Computer Lab Civil Department. Thank you, everyone.
Before proceeding for lunch break, I want to propose a special thanks to Dr. Vikas Kumar Vidyarthi sir for taking his time out of his busy schedule and sparing his invaluable time with us. He accepted our invitation and physically managed to come here all the way from NIT Raipur to our institute, VIT Sundri. Thanks a lot, sir. And one more thing is that he is also a senior from my BTech college. So thanks a lot, sir, for joining us here. Thank you.
Thank you, everyone, for your patience and for your attendance. Now we will move for a lunch break, and after the lunch break, we will meet in the Civil Department Computer Lab. UG student will be seated here.